Hi everyone, in this video I'll briefly explain all the APIs. So let's proceed. Here you can see that I have this demo apps repository. So let's see. So currently we have demonstration apps for GPIO, PWM, ADC, I2C, SPI, UART, CAN and USB. Next you can see we have a repository for BBBAndroidHAL. So this contain all the native code for the APIs. So I will briefly walk through the code and explain you all the APIs. So let's proceed. So here you can see that in BBBAndroidHAL repository we have 3 folders for Cape, Docs and GNI. So you can find all the APIs in this GNI folder. In this GNI folder we have this include. This include folder contains all the header files that are necessary for compiling the code. Then we have this temp folder. I'll tell about why I have kept this folder. Next we have all the APIs, ADC, and let's go through it one by one. So first of all, this is let me explain you this android.mk. So this android.mk file is used to compile the binaries using the APIs and main.c. So this android.mk file basically helps us to directly run the code in the Android shell, so that we can use it before we can actually test the code before actually implementing on the Android application. So this android.mk is used for that. Then we have application.mk that specifies the Android API that we will be using. So Android 19 API. Whenever we are using this code to compile the Android application, then we need to modify this android.mk and application.mk file according to our application. So I have just put a demonstration this file that can be actually used to replace these files. So in my previous video you might have seen that I have simply copied and replaced these files, but actually you can modify those files if you want. So let me show you that. So this is the file that is used to compile the Android code. So here I have also included this libusb support that I have for usb.c. Then I have this android.mk. So these two files need to be replaced. With the files in temp to create an actual Android application. That we'll see further in the video. Now let's proceed towards the API. So first of all, let's see this adc.c file. So actually all the functions of the API can be found in BBBAndroidHAL. So you can see that here I have APIs for GPIO interfacing functions, then I have PWM interfacing functions, then I have ADC interfacing functions, so on, for all the APIs. So also you can find references of this API on the wiki. So this is the AndroidHAL wiki. So here you will be able to find simple steps for making Android application using BBBAndroidHAL. So here are the steps that are followed. Now let's see the ADC API. So you can just click on this API and it will open the API. Also we have the documentation available for BBBAndroidHAL on this page. So you can see that and you can find all the APIs by clicking this. 1 second. Yeah, so now you can see that this is the ADC API, and this is the documentation, this is deoxygen documentation of all the APIs. So if I click on this adc.c, so I'll be able to see the documentation. Here you can find all the references that you will require to understand the code, and in wiki you will be able to find the example code and the explanation of functions, what it does. So it will be pretty much easy to understand the code. Here you will also be able to find the sample application. So if you click on the sample application, it will open the code for you. So this is the sample application for ADC. Now let me explain you the API. So here you can see that I have a single function for read ADC. So it takes input the channel and it outputs the value, the raw voltage value to the raw voltage value in millivolts to the function. So through the function. So here in API you will be find that it takes the ADC channel number as the input and reads its value using the file system access and then returns its value. It uses it can be used using this type of statement. So it just gives output and it is stored in value. So here if you see the Android application for this, so here you will be able to see that I have just accessed this using the simple way, and then I am displaying it on the text view. This I have already demonstrated this application in previous video. You can refer that video if you want. So this was ADC API. Now let's proceed towards the next API. Let's see CAN. So here is the CAN API, and if you click on the sample applications, and it will open the sample application. Here also you can see the reference of all the code. So if you want to see what CAN open socket does, then if you click the link, then it will show what are the parameters and return values of this function and what it does. So this function takes socket type and protocol as the input and opens the socket of that type and protocol and then returns the file descriptor. So it is pretty simple to understand the code. This code is available here. So instead of just going through this code, you can easily refer it using the wiki and this deoxygen documentation. But if you want to just develop an Android application, then wiki should be fine. So I'll just be focusing on this wiki. Let me close this thing. So this is the wiki. So here we have open CAN open raw. So it just takes the port that we want to open, and it returns a file descriptor to access that device. So in the previous video I showed you that I wanted to access vcan0. So for that I have passed the parameter vcan0, and a file descriptor is returned to access that thing. Then we have CAN read bytes. So this function takes file descriptor and length variable to store length of bytes and read as input and return the pointer to the array of data bytes read. So it just takes the file descriptor and the so this length is just for storing the length that is being read, and it returns the pointer to the array of bytes. So in Java code this will be simply like this. Also you can find the JNI code related to these APIs. So just you have to just click the reference, so it will just open the JNI code. So here you can find the JNI code for JNI code for CAN. Just find the CAN. So here is the JNI code for CAN app. Here you can see that begin the JNI code. So here you will be able to find all the JNI code. So for CAN open raw, then we have CAN send bytes, then CAN read bytes, then CAN close. So I am talking about CAN read bytes. So this is simply like this. So Actually you can modify this JNI code according to your need. I have just demonstrated a way of doing that. You can easily use the APIs, that is the C code for all your purpose, and you can use this C code in your JNI wrapper functions and use them in Android application. If you want to use these JNI codes that I have made, then you can use it also. You have to just modify the class name for your application here. So like if I have in this I have shown that I am using this for GPIO Android application. So I have here GPIO main activity. So you can easily modify these things and access it accordingly. So this is the explanation for CAN API. Next also we have CAN send bytes. So for this we take CAN file descriptor, then unsigned int number of bytes and the array of data that we want to send. So if it is successfully sent, then it will return the number of bytes sent. Then this is the simple code for Android for doing that. Then we have CAN close, so it just closes the file descriptor. This is a screenshot of the Android application that I have made for the demonstration. You can also refer to its video that I have available in my playlist. Next we will see the GPIO API. So this is the GPIO API. So you can find the code here and the JNI reference here. So code is simple. We just first open the GPIO, then when we want to read, then we read the GPIO. When we want to write, we write the GPIO, and then we close the GPIO. So like here we have opened the GPIO in on create function, then on button poll status, then we read GPIO. So on header 9 and pin 27 of header 9, then accordingly we change the text view. Then we have light on off, so we write the GPIO. So we write the pin 11 of header 9 GPIO. So this is the simple code. And now if we refer the API, then we have open GPIO. So it takes the parameter 0 or 1. If 0 is passed, then GPIOs are accessed using the file system. If 1 is passed, then GPIOs are accessed using memory map. So this is simple. Then we have read GPIO. It takes the header and the pin number that we want to read, and it just reads the GPIO. Also you may need to provide the permissions, proper permissions to access the files. You can refer my GPIO video for how I have provided the permission using chmod. Next we have write GPIO. See, in write GPIO we have we have a header, then pin, then the value that we want to pass. So in this way we can write the GPIO. Then we have close GPIO to close the file descriptor. So this is the GPIO API. Next we will see the I2C API. Similarly, you can if you want to see the code, you can easily find the code here. So let me show you just the Android code. So this is the Android code. So here you can see that I have open adapter 1. So I am accessing I2C 1. So our file descriptor is written. Then I am doing set slave. So to access the device presented address 0x53, I am doing set slave. Then I am reading a byte from the address 0x00, so it will return a device ID. Then I am doing write for power control register. Then I am doing write bytes. So I have demonstrated all the APIs in this app. You can find more references of this app in the previous video. Now we will see the I2C API. So in I2C API we have I2C open adapter. What it takes the adapter number as input and returns the file descriptor to access the I2C device. Then we have set slave. So in the previous video we saw that when we want to access a device, we have to set that device as the slave to I2C. So our device was connected to address 0x53, so we have to set slave for that device in this manner. Then we have I2C set address. So for that so if we want to randomly access a register, then we use I2C set address. So so that we can directly jump to that location and access that address. Then we have write byte. So for write byte, we provide the address and we provide the byte we want to write, and it writes to that address in this way. So you can see the example. Similarly, we have write bytes. So we have the starting address, the length we want to write, and the bytes that we want to write. So it will start from the address and write the length number of bytes from that address. So this is right. Then we have read byte. So it will return a byte. It will read from the address provided and return a byte. Then we have I2C read bytes. It reads the length number of bytes from the given address and stores them to the buffer array. So in this manner you can use it. Then we have I2C close. So it will close the file descriptor. This is the screenshot of the I2C Android application that I have used for demonstration. So here you can see that I2C device is connected to through this and this chip ID is present here. Next we will see PWM API. So this PWM, let me show you the Android code. So this is the Android code for PWM API. So we have PWM set period, get period, set duty cycle, get duty, run, stop and check. Then again you can find full video reference of this in my playlist, but I'll briefly explain you the code. So let's see. So I have this. Okay, so here you can see that on click button poll status. So when poll status is pressed, then it will check the get duty cycle of PWM PWM 0, then get duty cycle of PWM 0, then run check if it is currently on or off. So this is done using on click button poll status. So and it is displayed in a text view. And next we can set the period and duty cycle. So we have a edit text present. We provide the input of period and duty cycle, and it is set on PWM 0. So in this way we set the PWM. Then we can start the run using PWM run 0. We can stop the PWM using PWM stop. So this is the Android application. Let's see the API. So here you can see that I have PWM set period. So it takes the channel. So PWM channel. Then we take PWM period in nanoseconds. So here I have provided 10 lakh as the period in nanosecond, and I am setting the period of PWM. Next we can get the, so this getter and setter is pretty handy when we want to view what is the period duty cycle of the channel. So this is to see the period. Next we have PWM set duty cycle to set the duty cycle of PWM channel 0. Next we have to view the duty cycle of channel, any channel. Then we have PWM get duty cycle. Next we can set the polarity. Similarly we can get the polarity. Next we have PWM run. So this run takes the channel as input and it just set the run to 1. So it will start the PWM. Similarly when we do PWM stop, it will set the run to 0 and it will stop the PWM. Next we can, if you want to check if PWM is currently running or not, then we can use the PWM run check. It will return the value of run. Now let's see SPI API. So similarly you can see the Android application for this. Here you have SPI open, then you have bus, then you have device, then you have speed, mode and bits per word. So these things you have to set, then a file descriptor will be returned to access that SPI device. Then you have SPI transfer. So if you want to transfer some data or receive or send a data, then you can use it. So here is a way. There are many other ways to do SPI transfer depending upon your need. So this is one way. Next we have so this will actually send this one, it writes 0x08 at 00 address. So next we have SPI read byte. It reads a byte from the given address. Then we have so these functionalities are pretty much similar with I2C. Then we have SPI read bytes. So it will read the length number of byte from the starting address and return a array of bytes read. Then we have SPI read byte. So it will read a single byte of data, and this function this will write a single byte of data at the address. Next we have write bytes. So it will write the length number of data from the byte array to the SPI device. Then we have set mode. So it is used to set the mode of SPI device. We can set the speed and bits per word of the SPI device. Then SPI close is used to close the file descriptor. This is an example of SPI Android application that I have developed. Here is the code. Here you can see that I am using SPI open, SPI write byte and SPI close. So SPI open is this code. Then we have we are doing SPI write byte. So according to the case I am writing that byte into SPI byte. Then we have SPI close. So this is the code. Next we see UART API. So this is the API. So in UART we have UART open. This UART open takes two arguments. One is the device and the baud rate that we want to set. So here you can see that I have set 9600 baud rate to 4 UART 4, and it returns a file descriptor to access that UART. Actually you can use only these number of baud rates, so like 0, 50, 75. Other than that it will not work. It is defined in this code because a proper return value is required to access them. If you want to change the code, you can easily change the code, and you can support other baud rates, but currently it supports only these number of baud rates. Next you have UART write. So in UART write we have UART file descriptor length and the array of bytes that we want to write. So it will simply write the length number of bytes from the array provided. Next we have UART read. So it will read length number of bytes and it will store it into the array of bytes. And then we have UART close. And it will close the UART file descriptor. This is the screenshot of the UART application that I used for demonstration. Let me show you the code. So this is the code for the UART application. We have UART open, UART write, UART read and close. So here you can see that I have opened a UART 4 with 9600 baud rate. Then I am on click send, I am sending the data to UART. Then I am on click receive, I am receiving data till null is encountered. Then I am closing the file descriptor. Next we will see USB API. So actually USB API, this is not a complete API. I am using libUSB as the base for this thing. This is only a demonstration how libUSB can be integrated to this application, to Android application for BeagleBone Black. So if you want to use any other functionality of libUSB, then similarly you can just add the functions and you can access it. You have to just make a JNI wrapper and you can access it into Android application. This is just a demonstration. So for this demonstration I have made 3 functions. One is USB init. So this will just just create a USB session and gets the number of devices attached, and it will return that devices. So this is the example. Then this is a USB get devices. So it takes the 2D array IDs and 3D array strings, and it will fill it with the IDs of the USB devices attached and the string descriptor of the manufacturer and vendors in the strings. So next we have USB close to close the USB session. So this is only to demonstrate a LS USB type functionality that I wanted to demonstrate. So you can easily use libUSB APIs to integrate it with your Android application. So this is the screenshot of the USB Android application. Let me show you the Android code. So here you can see that I have USB init. It returns a count number of devices, USB devices attached. Then we have this USB get devices. I pass buffers to store the IDs and strings. Then it stores everything and it is returned. I'll just making a single string to display. Then I'm displaying that into a text view. Then I have USB close. So this is a simple application. You can find description of all these API and related demo apps in previous videos in my YouTube channel. Also, if you want any help, you can easily mail me at ankurayadav@gmail.com. So now let we have known about the APIs, let us make a simple application for a quick review of the APIs. So for this application, what we will be doing is we will be making an application that can utilize all the peripherals of Beacon Cape. So in my Beacon Cape, I have a ADC slider input. Then I have a 7-segment LED that is connected with SPI shift register. Then we have an PWM LED, and we have a GPIO input. So I'll be using all these and we will be making a quick Android application for the Beacon Cape. So let's proceed. So this is the code that I have made. I'll explain you this code, what I have made for this Android application. So here you can see that what is a Beacon Cape like. So this is the PWM controlled red, green, blue LED light. This is a 7-segment LED display that can be either controlled by GPIO or SPI. Then we have a slider input for that is connected to the ADC. Then we have a button for GPIO input. So this is the cape that I am using. So let's see the code that I have made. So this is the code. Let me explain you it briefly. So I have 2 classes here. One is hardware task and another is main activity class. So this hardware task extends the async task. So for any hardware related task, we actually use async task because it may take some time. So it is better to run in background rather than running it on the main class. So I have made that. So for this Android for this application, I will be using the GPIOs. For GPIO input from the button, then we have PWM for PWM, then we have ADC, then we have SPI. I am also demonstrating if we can include the USB device. So what we have to do is first we have to first of all create a GNI wrapper for them. So let me show you. So here you can see that I have included two things. I have changed the android.mk file and application.mk file in the directory. That I said that we have to change first of all for making any Android application. Also we can see that in include folder we have a libusb folder. So this is the library for libusb that I wanted to tell you that so this is the whole API for accessing the USB. Then we have some header files that are missing from our image that we have to add. So for CAN and SPI, so this I have added in there. So when we compile, these are all included. Then we have GNI wrapper. So in GNI wrapper I have changed the location of the, so this is the class of the path. So I have the beacon application and hardware task, so it can be properly linked. I have kept everything else the same, but you can modify it if you want. Now before compiling the application you have to just build the code. So actually I have already built it, so it will just build the code. Then what I have done is, let me show you the graphical output. So in graphical output I have just kept the output for the for listing all the USB devices. Other than that we will lively see it on the beacon board, the change of PWM and the slider control and the GPIO. So what I will be doing, let me show you. So here is the code. So on pre-execute it will just initialize the file descriptor for SPI, it will open the GPIO and it will initialize the session for USB and it will return the number of count. Then do in background, so it will be done continuously in background. So it will just set the period of 3 PWM channel 0, 1 and 2. So these 3 PWM channels are actually red, blue and green lights that are available on the beacon cape. Next we will run it in while loop, so it will continuously be running in background. So it will read the ADC5 and it will convert into a proper duty cycle and it will pass it into the PWM channel. So as and when we will be changing the slider of the beacon cape, then intensity of the light will be changing accordingly. We will see that in a minute. So next we have is we will be sending the PWM the value of the slider on the 7 segment LED. For sending that I am using the SPI. So here we have send value. So according to the duty cycle, send value will be calculated. So it will be calculated and a byte value will be returned for the 7 segment LED. This value will be written using the SPI write byte and it will write it into the 7 segment LED. Next we have is our GPIO pin for beacon cape is actually connected with the 19th pin of P9 header, and so it is if it is pressed then it will switch on the LED, and if it is again pressed then it will switch off the LED. And then I have provided a delay for proper pressing of the key. Then we have, so in here you can see that I have poll device button. So when a poll device button is clicked, so on click of poll device button I will call the poll device function of the hardware task. So here is the fold device function. So fold device function will actually pass two arrays, and it will and then display the IDs and strings of the USB device attached to the BeagleBone to the display. So this is the Android application. So now let's run this application. So first of all, before running this application, we have to actually do two things. First of all, we have to install a proper device tree overlay, so that we can access we can properly set the GPIOs and SP devices and everything. Then next we have to provide the permissions to access those those pins, so that Android application can access them. So let's do that. So here you can see that this is the overlay that I am using. So here you can see that P9 header, 36 pin of P9 header is used as the analog input 5. Then we have 19th pin of P9 header is used as the GPIO. Then we have 3 PWMs. Then we have pins to access 7 segment LED using the SPI. So these are the modes that I have set. So I am installing this overlay into the device. So I have already compiled this device and pushed it into the BeagleBone. So I will just compile that. I will just install that on the BeagleBone. So I will just install them the overlay. So let's one second, let me first show you what is the current overlays in. So these are the current overlays that are installed. Now we will be installing a new overlay. One second. So you can see that a new overlay is installed now, and now we have to give proper permissions to the pins. So let's do that. So first of all provide permission to the GPIO. So let's do that. We have to export pin for that first. Okay, so we will for P8 19th pin of P8 header. So 19th pin of P8 header is GPIO 22. So we have to export GPIO 22. So let's do that. So then we have to give permission to access it. So actually we can also see the value currently. So here you can see that current value is currently it is 1. If I press the button, so I am pressing the button now, so it is 0. Again I am releasing the button. So let me show you it in video. 1 second. Okay, so here you can see that I have connected my BeagleBone. So this is the BeagleBone. Now let me show you the value. So currently it is showing 1. When I press the button, so I am pressing the button, Let me see. So I am pressing the button, so now you can see that it is showing 0. So this is the GPI value. Now let me so let's give it permission. So chmod, let's just see the value. So currently it is not having the proper permissions to access from Android application, so let's give it proper permission. So now it has the proper permission to be accessed. Next we will give proper permissions to the PWM LED. So let's do that. So here I have expected the PWM 01. Now I am exporting PWM 2. So here you can see that we have PWM 0, 1 and 2. We have to give provide permissions to them. Before that, let me give you briefly how to access them. So let's do that. So I am giving period. I am setting the period. Now I am setting duty cycle. Duty cycle. Then I will set run. So before that, let me show you the output. So here you can see that LED is not glowing currently. So I am pressing the run. So now you can see that red LED has started glowing. Again, if I put the run equal to 0, then it will stop glowing. So it has stopped glowing. So this was PWM. So we have to provide proper permissions to all of them. So let's do that. So now we have permissions for duty cycle, period, run. Let's provide it also for the polarity. So we have to provide this for all the 3 channels. So I am doing. So I have provided proper permissions to all the PWM channel. Now let's provide permission to the ADC. All this I have done in my previous videos also, so you can refer that also. So here you can see that the raw input voltages are shown. So I will be using the channel 5. So voltage for 5 channel. So currently it is showing the value. Now if I change the slider, so let me move the slider. So I am slightly moving it upwards, so it will decrease the value. It is decreased. If I move it downwards, then it will let me show you if it is okay. So I have changed it to downwards, then value is increased. If I move it upwards, then value is decreased. So let's provide a proper permission. So here you can see that now proper permissions are available with ADC5. Now last we have to give provide permissions for SPA device. So So let's do that. So chmod //spi. So proper permissions are set for SPI. Now we can actually run our Android application, and it should work fine. So let's do that. So I am now running the Android application. So now Android application is up. Let me show you the output. So this is the output of the Android application. Actually we have still a permission remaining to access the USB device, so let me provide it first, then we will proceed. So now let's provide permission to the USB devices. Okay. ///USB. So chmod, let's provide it for everything. Let's check it. So now you can see that we have proper permissions for everything. So now let's run the application. So our application is now running, actually running. So let me show you it one by one. So let me show you the display. So here you can see that currently display is showing 0. Now whenever I will press the button, then PWM LED will start glowing. So now you can see that it is glowing slightly. Now if I move the ADC slider, so if I have moved the ADC slider, now the intensity of PWM has increased. Now if I increase it further, then intensity will increase furthermore. If I change the if I decrease the ADC slider, then the intensity has stopped. Now if I press the GPIO button, then PWM light will go off. So now PWM light went off. Here you can see that 7-segment LED is also constantly changing as and when I am changing the ADC. So if I move the slider, so I have moved the slider and it has the 7-segment LED has changed. So it is working. Now let me show you the USB. So this is the display. Now if I will press on the pole, I will press on the pole device, then it will show me all the USB devices connected with BeagleBone. So it is showing here number of USB devices found are 5, and it is showing everything. Let me show you this graphical out clearly. So this is the graphical output. So we have number of USB devices found is 5, and these are the devices that are attached with the IDs and the strings for manufacturer and serial number. So this was the application. So in this application you saw that we can integrate all the APIs in a single application. In similar way, if you want to develop any application that you want to utilize more than one API, so you can make that application. So if you want to get in touch with me, then you can email me at ankurayadav@gmail.com, or you can find me at IRC on Beagle GSOC with nickname Ankur. Thank you.